Okay, so with this one, we're going to look at isomorphic, or the other word for it is equivalent. So what does equivalent mean?
Same as.
Yeah, same as. So an isomorphic graph it's the same situation in terms of it'll have the same vertice number, it'll have the same edges, and they will go to the same, they'll connect exactly the same way. The only thing that it will visually look different, but it is actually the same thing. So it's an isomorphic network. And then we're going to look at adjacent matrices, which you have already done. So we're just refreshing that one. So let's have a look at a connected graph. So in a connected graph, every vertex is connected to every other vertex, either directly or indirectly. So what that means is, so if you have a look, say, I'll look at on this one. So say A is directly connected to D. But it is also, so you might say, if you want to write that, you could say A is directly connected to D. Now, if I looked at A again, so if I go from A, or if I look at A and B, I can get from A to B, but I'll go through C. So what that is, when you refer to that, that is A is indirectly connected to B. All right, so what a connected graph is that you can sort of get to every vertex. It's pretty much from another one. If you think about it, without lifting up your pen, if you were tracing along, can you get there without having to lift up? All right, so that's a connected. So if you look down here, say in this example here, we've got a couple. We're referring to this one. This one's not connected because if you think about it, if I'm at D and say I want to try and get to B, I can't get there. I have to lift my pen, otherwise I'm going to create, something that's not there. I'm not tracing along. So what we have, that is not a connected graph. So this one too, you might just want to write, that's an isolated. So isolated meaning by itself, yeah? Isolated vertex, we call that. So that is a disconnected graph. So say in not connected, so you can see here in this second example, we had the D is also another isolated, so it could not be a connected network. And then this last example, it's still not connected. We've got two of them joining, but we can't, there's no bridging between them, so it's still not connected. Okay, so that's what a connected. So when we have what I just said, if you have an edge that if it was taken away makes it disconnected or not connected, that edge must be called, it's called a bridge. So you can see here in the example, so a bridge is an edge that if removed leaves it disconnected. So can you see if I took that away, that one edge, the triangle part and the circle are going to be they're not going to be connected. So that thing becomes disconnected. So when you see something like that, when you have an edge like that, that is called a bridge. So that's a bridging piece. So if I removed it, and you can have more than one in a network, there might be more than one, so it doesn't have to be just be one bridge in a network. We could have multiple bridges. Okay, so now we're going to look, so now we know these few little facts. We're going to look at creating an isomorphic, which is an equivalent graph. So graphs that have identical, so remember that's important, identical information. So it has to be the same, like if there's two paths between A and B, there has to be two paths in the alternate or the isomorphic graph, the equivalent graph. All right, so it'll have the same number of vertices, same number of edges, and same connections. So for example, the three graphs below look quite different, but graphical terms, they are equivalent. So maybe just write also in the bracket, isomorphic, because what they're going to use isomorphic, and you're going to forget what that word means. So it just means it's equivalent. So let's have a look. So to show you, if I look at A, and let me see what A is connected to. A is connected directly with D and C. So when I look at all my other graphs, I should see that as well. So can you see it's directly connected to, so that's the same, and here I've got that direct connection. If I look at, say, another part, say B, B is directly connected to D and C only. So if you look at B, yep, C and D, that works, C and D. So that is still all the same. And the last little bit, if you look at D and C are connected, well, there's the connection and there's the connection. So they're exactly the same. It's just visually looks different. So you just got to be really careful and make sure. So this is probably a little tactic you could use. Get your highlighters out and then make sure that you're matching the same way. All right, so an adjacency matrix, we've already done this, so we should all be acing this without a problem. So they're useful when the information in the graph needs to be entered into a computer. So what happens is you're given the network. Here's the network graph. And they want that information put into a computer. They need to put it into the matrix format. So let's just show you, just to remind you. So if you look here, between A and D, there's 2 edges. So you're going to see between A and D and A, there's that 2. Okay? And then if you look between A and B, there's 1. So you can see on those options, we're seeing the 1. Between A and C, there is 1. So in those options, can you see that there? Here, we've got C has a loop. So that's on that diagonal. There's that loop. Okay, and then if we're looking for another one, we could say, B and C have that. So if you, oh no, we already did that. Did I do it? B and C, sorry, there. And C and B. There's that one. And then there was zeros everywhere else, so there's no connections. So you should remember, do you remember doing this? Okay, so now what they're going to do is they're going to give you the matrix and ask you to draw the network. So I've got to draw the network here. So what you're going to do is, the first thing to do is draw your vertices. So I'm going to be a bit more exaggerated with my dots. And there you go. So I've got, these are my vertices. Okay, then I'm going to look at, and I might just go across here and I look across there. So A is connected to itself. So then what's that going to look like on it? It's going to be a loop. So there's that one. If I go across here, I see a 1. B is connected to C and D. So B, oops, sorry. C, C and D. Okay, if I go looking across at, we've already done the C and B, and then if I just look at D, D is also connected to B. Like that. Okay, so there's our connection there. So I didn't have to do this one because I've already got that there. We'd already drawn it when we did the B bit. All right.
Why is the blue there?
Sorry?
Why is the blue there?
You're true. Sorry, we didn't need this one there. Good point. All right, so that's how we should look like. Now, what did we call this one out here?
ISO.
Yeah, this is an isolated one. And is this connected or not connected?
Not connected.
Yeah, this is a not connected graph.